Hi, good morning, Professor Adrian. It's not morning for you, is it?
It's nighttime here, California.
Oh, I see. How are you doing? I hope you're doing good.
Very good, thank you.
So, can you please share your screen so that we can just have a small test to see
Sure.
if we can hear you and see the screen?
Right.
Hi, everyone. I hope you are all keeping safe and well. I warmly welcome you to the second day of ICTer 2020. We have several interesting sessions planned for today. So the first day of the conference was held yesterday and it was quite fruitful with two informative keynotes presented by Professor Ray Buntin and Senior Professor Nihal Kodikara, and over 40 research papers and poster presentations lighted up the day for most of us. So to kickstart the second day, we have a keynote speech which will be presented by Professor Adrian David Chiok. Professor Adrian Chiok is a full professor at University Tokyo, Japan, director of the Imagineering Institute of Malaysia, visiting professor at Raffles University of Malaysia, and visiting professor at University of Novi Sad of Serbia. He is the founder and director of the Mixed Reality Lab of Singapore. He was formerly the Professor of Pervasive Computing at University of London, full professor at Kyoto University of Japan, and associate professor in the National University of Singapore. He has previously worked in real-time systems, soft computing, and embedded computing in Mitsubishi Electric Research Labs in Japan. Professor has been working on research covering mixed reality, human-computer interfaces, wearable computers, and ubiquitous computing, fuzzy systems, embedded systems, and power electronics. Professor Adrian Chiok has successfully obtained approximately $30 million in funding for externally funded projects in the area of wearable computers and mixed reality from numerous ministries, authorities, and foundations. He has been a keynote and invited speaker at numerous international conferences and events. He was awarded the Hitachi Fellowship, the A-Star Young Scientist of the Year Award, and the SES Singapore Young Professional of the Year Award. Professor Chiok was also awarded as a Young Global Leader by the World Economic Forum. He's joining with us today all the way from USA. So ladies and gentlemen, please welcome Professor Adrian Chiok.
Thank you very much. So, hello from California, USA, and I'm very happy to join this conference. And also, I visited Sri Lanka several years ago, and it's a wonderful, lovely country, and I can't wait to visit again to Sri Lanka. And so, thank you for inviting me. Today, I'll talk about the research that we've been doing the past decade or so on multi-sensory communication. So this talk is titled Every Sense, Everywhere Communication. So I'll talk about how we can communicate not just with audio-visual, as we're doing now, but also with all of our 5 senses, including touch, taste, and smell through the internet. Let me talk first about vision. And right now you can see me, see my slides, so we can, we really got started in this topic. We were doing a project in Singapore, and we were doing a project for the Defence Science Technology Agency in Singapore. And at that time, it was the early 2000s. And at that time, it was actually very, very complicated to do augmented reality, which a lot of you know can merge the computer graphics 3D world with the physical world. And so now we can do it with a mobile phone. So there's been a massive increase of technology power in the last 20 years. But 20 years ago, we were doing this research, and we built the actual head mount displays, and we had wearable computers, and it was all very, very expensive, millions of dollars of research. So just in case you are not familiar so much with the topic of mixed reality, it's basically the continuum of the real world and the virtual world. So of course we know the real environment which we are born in and we live in every day, and the virtual reality of games and a lot of entertainment. And in between we have augmented reality. You can see like a virtual 3D object, and you can see 3D frog, and you can see it as if it appears in the physical world. Augmented virtuality is not so well known, not so common, but it's basically putting the physical world in 3D into the virtual world. So you can see we captured humans in 3D and we put them into the virtual reality environment, and you can see in that video there there's a virtual environment, but you can also see the virtual the real human captured in real time and put in the virtual environment. So this transition is from the real world to the virtual world, called mixed reality. So we made the system and we built the hardware, as I mentioned, and I decided that we can make new kinds of interaction and entertainment with this wearable computer and head-mount display system. I really enjoyed playing Pac-Man when I was a little boy, and so I thought, wouldn't it be really man where we can become the Pac-Man and we play with other real, and then we have a correspondence between the real world, you can see on the left side, and the virtual world. So basically the real world person puts on a computer and can see the virtual cookies and if you look on the right hand side, you can see that as the human Pac-Man eats the cookie, then it corresponds to the virtual character in real time in the virtual world. And let me show you a video of this now. Hopefully the sound will be, you can hear the sound.
We cannot hear the sound, Professor.
I see. Maybe I should reshare again.
Okay.
Okay. Okay. So hopefully this will work.
A wearable computer
Yes.
with a head-mounted display and various sensors which we have, which is sensing my body's position and as well as the head orientation. So we know exactly where I am and what I'm looking at. So when we do this, we can then augment the real world, which I am in now, with the virtual world. So this Pac-Man world, I'm seeing it as part of the real world. I can see cookies in front of me and I'm walking through them as if I'm the human Pac-Man.
So that was a video you can see of the system that we made. And like I said, now you can do that on your mobile phone. So we've gone in less than 20 years from something which cost, $1 million to something which costs maybe a few $100. So that's an amazing increase of the technology. We can all play these augmented reality games with our mobile phone. I think the most famous one was you can probably remember the Pokemon Go, which came out a couple of years ago. It's probably the most famous augmented reality game. But let's look at not just the video, but also sound. We also did some projects on augmenting our sound with interactive content. And in fact, probably the earliest form of augmented reality was in fact sound, because when Sony introduced the Walkman, we could hear virtual sound in our ears. So I think sound was probably the first kind of augmented reality. And to show you an example of work we did several years ago, it was called the Magatana, which is basically like a kind of a samurai sword. We did this in Japan, at Keio University in Japan. And with this device, you could have a virtual game with audio. augmented reality. So let me show you a video of this system now. So you can see there, with just using sound, actually you can make quite an entertaining system by augmenting sound with the physical objects. And so now I want to talk about the main part of our research. We wanted to go beyond audio and vision, and we researched in virtual touch and taste and smell. So first of all, let me talk about touch. And this is where we can transmit touch through the internet. And one of the first systems that we did in virtual touch was this system called Poultry Internet. And it was a remote human to pet touch communication system where your pet, in this case it was a pet chicken, through the internet, you physically touch a doll which has some pressure sensors, and this will transmit to the vest that the chicken is virtual touch through the internet. And we wanted to go beyond that, of course, with human to human virtual touch through internet. So we made a system called the Haki Pajama, which was a remote bidirectional hugging system. And the idea is that the parents and children could virtually hug each other through the internet. If, for example, the parent is at work or on a business trip, or the child is at school, then still they can send a virtual hug through the internet. And this is a bidirectional way of touch and hugging through the internet.
The future is coming fast, and your world will never be the same.
The future we hold.
There are few things in life more comforting or intimate than a nice, big hug.
Notice the
No
sense
technology. It was awesome.
At the Mixed Reality Lab in Tokyo, Japan, Dr. Adrian Chiok and his team are making it possible to reach out and hug someone, even if that someone isn't there.
Adrian, at this mixed reality lab, you have a lot of strange things going on. I can't figure this one out. It looks like a cross between a torturous life vest, rain jacket. What is going on, and who is this?
Well, this is Nancy, my student,
Hey,
and
Nancy.
mixed reality is not just about visuals. It's also about mixing all of our senses with the virtual world,
Okay.
including touch.
Touch. So this is a touch vest.
That's right. Through the internet now, you can email someone, you can do video chat, but you can't touch someone, you can't hug someone. So with this,
Oh, sure you can. No. I've seen people do it all the time. You put a little asterisk, you say hug, and then you put another asterisk, and then they know you've sent them a hug.
It's so important for human communication to touch and hug each other.
So Justin Timberlake brought sexy back. You're bringing hugs back.
That's right.
How does this replicate a real hug?
And if you just give a hug,
My expert hug.
yes. We did a study of expert huggers such as yourself,
Okay.
and where you put your hands is where we put our special hugging actuation system on the body.
Hugging actuation system.
So this system here
Yeah.
will replicate the feeling of where you
So
are.
it's going to apply some pressure where my hands would be.
Exactly. It gives a kind of feeling of the human hand caress
Okay.
on your body, on the body.
Let's see it work.
With Nancy far, far away in another location, Adrian takes out a controller and transmits his virtual hug via the internet.
And then you can see that this hugging pajama is connected to the internet, produces the hug in the same spot. We can both wear such jackets, and then interactively we can have a hugging and caressing together through the internet.
What if I wanted to...
So you can see that was an early prototype of our internet hugging system, and you could, as you can see through the internet, you could virtually hug someone, so reproducing a virtual touch or virtual haptic sensation. We then wanted to make something smaller because obviously most people don't want to wear hugging vests all the time. So we made a device called RingU, and this was a device where you could produce a virtual touch with a mini ring. So, for example, you can be in 2 different countries, and you can send a haptic message to someone's ring through the internet, and it can connect to the internet. So, for example, you could select some of your friends on the Oops. Hello?
Yes, we do hear you, Professor.
Okay, I have to share. Can you see my slides?
Yes, we can see them.
Okay. So you can see here an example of the rings that we developed in our laboratory. And they're a little bit big because they were lab prototypes, and we built them with our students, but it was a successful prototype. So then we started to work on this device called Kissinger, which is a kiss messenger, and we thought, wouldn't it be interesting if we could not only hug or touch through the internet, but also kiss through the internet. So this device here, the concept was that you could send a kiss to your friends or family through the internet. And it's a device that you can put onto your smartphone, and you put it onto your lips, and it detects the pressure from your lips and sends that lip pressure to your friend through the internet. So you can do a video call and send the kiss at the same time. So an example is let's say a father is in Sri Lanka and the daughter's in USA and just won a scholarship to MIT. So you can not only give a telephone call, but also father and daughter can give a kiss through the internet. So this is an example of the many uses of this device. Here's a video of the machine.
So this is Kiss Messenger, or Kissinger for short. With this device here has pressure sensors to measure the pressure from your lips.
So you can experience the pressure of a simultaneous bidirectional snub.
Yes, that's right, yes. But through the internet.
That's amazing.
You can be separated by thousands of kilometers and kiss each other.
Kissinger is a great way to bond with the parents and children when you're away at work overseas. We have high-precision force sensors that are embedded under the silicone lip to measure the dynamic forces at different parts of your lips during a kiss. And the device will get this data from your lips and send it to your phone, which will in turn transmit the data to your partner through the internet in real time. We also have miniature linear actuators that are used to produce the same lip pressure on your partner's lips, and your partner will be able to kiss you like a real-time kiss through the internet. You can have a video call with your partner and use Kissinger as a way to connect to your partner through the internet in an intimate way. Research has shown that touch is a very important interaction, especially for human relationships. And through the internet, you can only see or hear from your friends and families, but you can't really touch them. With Kissinger, you can actually have a video chat with your friends and families over the internet and kiss them at the same time. It's a great two-way interaction and it feels like a real kiss.
Well, that device actually was developed when we had Imagineering Institute in Malaysia, and also just want to mention that part of our lab was Dr. Kasun, who's I think and is now assistant professor at your university. So he was a great help for that project and many of our projects. Now I'll go to the final part of the talk, and we'll talk about smell and taste and how we can transmit taste and smell through the internet, which sounds a little bit maybe unusual, but we wanted to see, can we transmit these final senses of our body, taste and smell, through the internet. Now, you might be thinking taste and smell not so important compared to our other senses, but one thing which is important is that the taste and smell, which is coming from the tongue as well as the olfactory receptors in the nose, they are linked closely to the emotional centers of our brain. So smell and taste has a very strong link to memories, feelings, and emotions. So not only in the real world, but in the virtual world, it will be really important and interesting to transmit taste and smell through the internet. The problem with smell and taste is that it is not like sound and audio, which are, as you know, frequency based. They're waves. So audio is a sound wave, and light is a light wave, and it's actually conceptually relatively easy to reproduce sound and audio, because any kind of frequency can be converted to a number, and you can just send the number as a bunch of digital bits through the internet. But because taste and smell does not correspond to frequency, then it's very, very difficult to transmit this through the internet through electrical signals. But people have been working on this for quite a long time. So in fact, in the 1960s, here in California, where I am now, there was an inventor who worked on a device called Sensorama, and it was, I think, one of the world's first virtual reality systems. But if you see on the left, it also included aromas, which are smells. So people have been thinking about this kind of concept, virtual smells, for a long time. And at first we worked on a device which is using chemical smells, and it could be developed in, it was developed in Japan, and it could be connected to the smartphone, and release chemical smell. So you could send a message to someone and it will output a smell. And you can see the prototypes that we built, and got smaller and smaller until they got to the size of a phone that you could plug into the bottom of your phone. And this is what the device looked like when it was commercialized. We worked with a businessman in Japan, and they turned it into an actual product which was on sale in Japan. So here's a video of
Food is inseparable from the history of mankind. And now, 2013, introducing a whole new approach to food, tasting and savoring food with your nose. How to 1, choose. 2, insert. 3, smell. 4, eat. And that's all there is to it. So, are we ready to savor this? Let's say you're a student with no money. All you need is some white rice and your stomach will feel satisfied. Let's say you're a woman on a diet. Obviously, calories are not an issue when you're dining at Hana Yakiniku. Now, let's say there's a couple going out on a date. We're pretty sure this will help bring them closer. Get a taste of this radically new deliciousness that mankind finally managed to develop after 7 million years of continuous evolution. The Big Bang in yakiniku, savored with one's nose. Hana Yakiniku.
So that was a device that was on sale in Japan for a few years. But we also made some interesting collaborations with a famous restaurant in Spain called Mugaritz. Chef Andoni, you can see on the right-hand side there with glasses. And he is a very visionary chef, and he, I think, one of the only chefs in the world that wanted to make a digital experience with real food in his restaurant. So we worked together with him to make one of his dishes, so you could virtually make the dish like a kind of computer game on your smartphone, and then as you made the dish, the smells would come out the phone. So it's very expensive for a lot of people to travel to Spain, and Mugaritz is like a Michelin star restaurant, so it's very expensive. But with this device, anyone can experience the smell of the cheap way. And so we released this device in the gastronomy festival in Spain, and it was released to a big acclaim. And so I think it was one of the very first devices that chefs used to transmit the to be able to let people to smell their food using a digital device. We also work with advertising companies, and so this device, we work with a company, an American company called Oscar Mayer, to advertise their famous foods. They're very famous for bacon. So we made a device called Wake Up and Smell the Bacon, which is a device where it was like an alarm clock, but you could wake up with the sound, with the smell of bacon rather than the normal ringing sound, which is a little bit annoying. So I'll show you a video of the advertisement they made for the device.
When scent embraces sizzle, who knows where that crispy compass will lead you?
At darkest midnight, the nostrils' North Star awaits you.
When imagination blossoms, only this scent will guide you to your greatest awakening. Wake up. Wake up. To the morning of your dreams. Only from Oscar Mayer.
So this device was, of course, to advertise the bacon, but it shows you some applications, I think, which it can be used in the real world to have smell, which comes from digital devices. So advertising, it would be a very good application for these devices. But as I mentioned before, the one bigger disadvantage of taste and smell is that they do not correspond to frequencies, so they can't be digitized easily. And the previous device I just showed you used chemicals, but of course, just like an inkjet printer, eventually the chemicals will run out, so you have to keep refilling the device. So to really make a true internet-based taste and smell, we need to digitize and produce the taste and smell using electrical signals. So first of all, we worked on electrical taste machine, where we could stimulate the taste receptors on the tongue using electricity. And so this is a concept diagram, shows you how we can stimulate the taste receptor cells to make a perception in our brain of a virtual taste. So we made a prototype of the device in our lab, and it became smaller. So I'll show you a video of the device where we could produce the electronic taste now.
I know you can't tell, but I am surrounded by the smell and taste of mustard and ginger in this hibachi grilled Japanese dinner.
And while I tuck into my deliciously real food, Shiranjit is exploring the health benefits of digital taste.
Here at the Imagineering Institute in Malaysia, innovators are adding a fourth dimension to devices and gadgets beyond what we can see and hear.
To find out more, I've come to meet Professor Adrian Chiok, who reminds me of the 5 traditional tastes of salty, sour, sweet, bitter, and umami.
Oh, I'm assuming that's umami.
A savoury taste which is often used as a flavour enhancer. Now, having limbered up my taste buds, I'm ready to go digital.
So let's try the
electric taste machine.
Electric taste machine. So
right.
what's it all about?
Okay, well, this device will stimulate your tongue only using electrical currents without any chemicals.
Right.
But it does it in such a way that it stimulates the taste receptors.
Right.
With normal taste, you have some chemicals on your tongue,
Right.
and it causes some ionization. And the next part is the electrical signal, which goes to our brain. This one directly stimulates those taste neurons, and you'll feel a virtual sour taste.
Sour taste. That's what I'm going to be
without
tasting.
any chemicals.
Okay. I'll try it now.
Yes. Okay. Okay. Your tongue's in between the electrodes, and I'm going to turn it on. And you should feel a sour sensation. Yeah, and now you can try a slightly different frequency, like more of a lemony taste.
Very interesting.
You can imagine in the future you can send taste signals without any chemicals.
Right.
So you can send it all over the world through the internet.
What's really interesting, lemon?
We deliberately use silver because silver and gold and some other metals have very little taste.
Professor Chiok and his team have also developed a thermal sweet machine. It stimulates the tongue through heat and thermal energy.
Great, let's try it out.
So have a seat? Yeah.
Sure.
So this, basically what you need to do is put your tongue under this silver electrode. Here we go.
Let's have a go.
You put your tongue there. And now I'm going to turn it on. And you can see, you'll soon feel temperature change. And hopefully you also feel a sweet sensation. And this sensation comes around from the thermal sweet effect that we have.
You're right, there's a very subtle sweet flavour. We've tried out the ability to deliver the sour taste and now the sweet taste, but how are you working towards machines that could deliver other taste flavours?
Imagine in the future, for example, salty, you have a fork or knife and you're eating like a steak and it's more salty without having salt, so it's healthier to have artificial salt. Just want to mention that Dr. Kusun is a professor at your university now. He was a very, very big part of these projects. So thank you, Kusun. So our next work was to produce a electronic-based smell. And for this device, we made a system which we inserted electrodes into the nasal cavity. And these electrodes would produce electrical stimulation of the olfactory receptors in the nose. And similar to what we just showed now, these electrical signals would produce artificial smell sensation. Of course, we developed this before 2020, so this seems like one of the most worst kind of systems ever, because you could directly give someone coronavirus, but this was before 2020, so we didn't know about that. And also, if anyone's taken a PCR test for coronavirus, I have done it one time, and it's very similar. You insert it right up to the top of your nose, in the top of the nasal cavity. So this system probably doesn't make sense in 2020 with the coronavirus. Let's imagine we're back to last year when there was no coronavirus, and you can see that work.
The digital stimulation of smell is considered as a useful step in expanding technologies and communication. Our previous work simply can produce smell sensation, and it is based on chemical odor molecules. These chemical odorants are not possible to transfer to the internet. Further, they have several disadvantages such as lower controllability, expensive, need to be refilled, and complex. Therefore, we need to find new technologies to transfer and reproduce smell sensations. So in this project, we focus to develop a new interface that can induce a on smell receptors and produce smell sensation. We believe by using a weak electrical signals can excite the smell receptors and generate smell perceptions. The digital smell device is equipped with adjustable frequency and current to produce electrical pulses. The stimulation process is carried out by putting a pair of silver electrodes inside the part of the nose where it touches the olfactory nerves. Generally, the smell-sensitive receptors are located near olfactory bulb and nasal content. Therefore, we stimulate smell receptor cells in this area to trigger smell-related perceptions in the brain. This electrode will be controlled by our special designed circuit that can deliver few milliamperes of current pulses to the smell-sensitive cells.
In our study, about 1/4 of the participants reported perception of different kinds of smell sensations, such as fragrant, minty, sweet, and chemical. This result shows that there could be an electrical path to generate smell sensation in human through electrical stimulation. We hope in future we can develop interface where we can regenerate the smell sensation using this device. Digital regeneration of smell will be useful to several industries like augmented reality, virtual reality, entertainment, online marketing, and gaming, where people can create and share information related to smell. In medical industry, this research will be useful to treat patients who are suffering from medical conditions such as parasomnia and insomnia.
Okay, so to summarize this talk, basically we are looking at how can we digitize taste and smell. Of course, in the future, the devices would maybe not look like the ones you see now, which are research into our tongue and nose. But I want to talk about how this could make new kinds of creative content, because whenever we develop new kind of media, then people will create new kinds of content, which is possible from that new media. So imagine we do have digital taste and smell as real products in the future. You could imagine that a little girl, a little boy could create food just using their computer or smartphone and transmit that through the internet. And maybe it's the grandmother's birthday, so they can create a digital birthday cake and send the taste and smell of that to their grandmother through the internet. So that's the end of my talk. We talk about how we can produce multisensory communication through the internet using touch as well as taste and smell. And I hope in the future that you can be inspired to work in these different senses for virtual and augmented reality. So thank you very much, and if there's time, I'd be happy to answer any questions. Thank you.
Thank you very much, Professor, for that informative talk. It was quite interesting to know the research in respect of mixed reality. Just like the name of your research institute sounds Imagineering, these research work, I believe, are highly imaginative. So I'm sure the audience has questions and opinions, as it was really interesting. So I'd like to ask our audience to come up with their opinions and questions if they have any.
Dr. Pirina from the UCSC. I'm actually a colleague of Kasun. I mean, it's a nice talk, interesting talk. How would you think mixed reality is in the future? What future presents for us? What can the future present for us?
Oh, very good question. So I think two tracks. One is the devices will become very, very small. So, for example, you can imagine that for augmented reality, we could have something very tiny like a contact lens, which you put in your eye, and then you can see augmented visual content. And as I just mentioned, maybe for the taste and smell, we have very tiny implants into our uh, receptors, which can produce artificial taste and smell. So I think one track will be devices will become smaller and smaller and cheaper. So people will use these for um, new kinds of communication, new kinds of entertainment. And then another track which may take longer, and I'm not even sure if it's possible, but another track would be that we might be able to directly connect to the brain directly. In fact, already we can stimulate the brain directly, the brain of simple creatures like insects and mice, and get them control the brain using electrical stimulation. Of course, we're nowhere near that for humans yet. But if you think about, in 50 years' time, maybe, or 100 years' time, maybe this will be possible. So I think ultimately, if it is possible, all this will be directly connected to the brain, and we basically be able to directly connect our brains to the internet, and so we bypass the receptors and directly stimulate our brain to produce augmented and virtual reality. As I said, I'm not sure if it's possible because the human brain is very complicated, and also people might not want to put implants into their brain, but that may be another future part of multisensory communication through the internet. Thank you for your question.
Thank you for your answers. A great talk. Thanks.
Thank you.
Just out of interest, when we think about vision and speech and so on, we know the kind of the ranges, right? In terms of taste and smell, do we have a kind of parameterization to kind of cover the entire range that we humans can sense?
Yes, it's a very good question. In fact, believe it or not, even in 2020, scientists, I'm an engineer, so there is people from the scientific research area who are studying more on the actual biology of taste and smell. But so far we don't really know very well how, in fact, the human body does taste and smell. We know for the tongue there is basically five kinds of taste, although some recent research is showing maybe there's 6 or 7 kinds of taste receptors. But the tongue is very simple from that perspective. There's definitely only a few kinds of receptors on the tongue. But for the smell, it hasn't really been determined how many smell receptors we have, and so it could be a few thousand, or it could be a few tens of thousands. But I think most scientists, it's definitely not in the millions, for example. So this just shows that audio and visual, we have much more sophisticated receptors, because we can see millions of colors, different colors, but for smell it's definitely in the thousands. So we are not we are not equipped with so many receptors of smell and taste, and probably other animals, for example, dogs we know have very much better smell receptor capabilities than humans do. Thank you.
Thank you.
I have a small question. Uh, if you, when you, I think we know that the taste could be, will be different for one person to another person, the same taste. So when you are simulating the taste or smell or even the feeling, do you consider about the status of the person? Because uh, when you wanted to give that feeling to that person, so the same thing could be understood by the person in a different way. So in the research, what you are doing, how do you manage that complexity?
Yes, it's a good question, and well, the only really way is to do a lot of tests on a lot of people. So that's what we did in our lab. We had you know tens and hundreds of people to use our device, and we would change the frequency and amplitude of the electrical current, and then we would then ask the human volunteers to to describe what taste or what smell did they uh, perceive. So that's the only real way to do it, because we have to get the feedback of real humans. So we did find that for certain frequencies and amplitudes that we could produce a certain taste, not in 100% of people, but in a high percentage of people. For the smell, it's I think it's much more difficult because only about 1/4 of our participants said they perceived a smell. So there's a lot more work to be done in this area, and hopefully the research can continue, maybe in Sri Lanka, hopefully. And there's a lot more work to be continued in that area because in our results, only about 1/4 people of the people perceived the smell, and also different people reported different smells. So still, as you mentioned very rightly, we still need to find a better function, input output function of electrical signals to smell, and that is a job that we must continue as researchers in the future.
So one more question. Now the police for investigation, they use dogs to drug detection and all these things. Is it possible to do some research with the dogs to replace these, help the investigation for these kind of things?
Yeah, so you're talking about smell perception, and so although our devices was aimed at the smell actuation, so producing smell from electrical signals, and I think what you're describing is the smell sensing, so converting smell to electrical current, and in fact that is actually much more easier, and a lot of companies are actually doing that now. You can companies are producing electronic smell devices to determine different chemicals, and basically, integrated circuit will detect certain molecules and then produce electrical signal if they perceive that molecule. So it could be done, as you mentioned, for detecting drugs, and I think maybe it's already been used for that purpose. But even for the food industry, for example, for those mass-produced foods, then where they're producing millions and millions of, like for example, chocolate bars, and you want them all to taste the same, then of course these devices can be used even for and are used in the food industry to make a consistent taste and smell for the food industry. So yes, we definitely can replace dogs for those applications you mentioned, and it's just a question of which is more cheaper. I guess dogs is probably cheaper than the machine at this stage.
Adrian, I'm Ajanta here. I just want to check this kind of research when you're doing its progress, like because all goes with the ethical clearance of human body and humans, so that how it's easy to progress, or like what challenges you have.
Yeah, it's a very good question. It's more and more difficult to do this kind of research. You know, when I first started this, you know, 20, 25 years ago, and I was in Singapore at that time, we didn't have to we didn't have to do any ethical forms. We just, you know, did whatever research we wanted to, basically. But now it's becoming very, very strict. So yes, it is more and more difficult to do this kind of research. I mean, I guess rightly so, because we have to be careful not to produce any harmful devices. But yes, now, you know, and in the later stage of the research, we had to do, you know, ethical clearance and get people to sign disclaimers and all this kind of thing. So it's just part of the steps of the research we have to do now. But yes, it is getting more and more difficult to do this kind of research. And I think you know, we were kind of lucky because we were doing the electrical smell machine in Malaysia, so it was a little bit easier to get ethical clearance. But if we did, I think if you're in Europe or maybe even USA, maybe it's almost impossible to do that kind of research without, because maybe the ethics board of the universities would not approve it.
Yeah, thank you.
Are there any more questions from the audience?
Excuse me, I have one question actually. This is about contextualization of whatever this research, because like you're talking about feelings and then emotions and like something fairly personal to somebody. So how are you going to contextualize? Because I have seen that you have applied it to many different contexts. And how do you basically maintain the balance or map the balance?
Yes, you're right. You're right. I think the fundamental motivation of this research is to produce, well, I guess at the very base level, to produce human pleasure. You know, so when I say pleasure, I say that in a very general sense. The fundamental aspect is we want to allow people to communicate, even if they're physically separate, to be able to communicate through the internet. You know, we have the internet, we can communicate all around the globe with the internet. And I think the fundamental motivation was that if we can have the multi-sensory communication through internet, this will increase the human pleasure or happiness, let's say. Although it's difficult to find human pleasure or happiness, so I don't want to, you know, it's very. I'm not a psychologist or psychiatrist, but so that's another aspect. We didn't really, you know, specifically measure in all of our work human pleasure or happiness. But I think that's the fundamental motivation. I think is the happiness and you know, pleasure of communication, and to if we you know, I think we believe that well, I believe that if we can increase the modes of communication, we can feel more happiness and more closeness, even if we're physically apart. And so actually this goes again back to 2020, and now we're all forced to not to travel, and there's a lot of lockdowns and schools are closed, etc. So in that case, yeah, I think increasing the possibilities and different modes of communication through internet is a very good example this year that hopefully if we have a multi-sensory internet, we can increase the human happiness and human pleasure.
Thank you.
Thank you.
Are there any more questions? Okay, so I think we can move on. So I think these are quite visionary work, and it's amazing how we can transfer sense